Hi, my name is Jian, and I'm the group leader for Group 5. Today, we will be talking about our database fundamentals project.
Hello, my name is Nak Wei, and I'll be showing you my part in the project. This is the part that I'm in charge of to generate a case scenario and to design a relational data model. This is the scenario that me and my groupmates discuss, and I try to implement it as best as possible. And another part that I'm responsible of is coming up with the business rules. And these are the 5 business rules that I thought about after discussing it with my group mates.
Hi, this is Qingqi. This is our entity relationship diagram. And in our diagram, we have 7 entities: disaster events, relief center, assignments, volunteer, recipients, distribution record, add item. Each entity has only one primary key, and then I put on the first row with their data type. The relationship between disaster events and relief center is one-to-many, and this means one disaster event can have many relief centers set up for it, and this connection is made via foreign key. Disaster ID field in relief center is the foreign key, and this references disaster ID, which is the primary key in disaster events. Next, we go to the assignment. Assignment ID is the primary key in the assignment table. And the relationship between assignment and relief center is also one-to-many. It means one relief center can have many assignments. Between the assignment and volunteer, the relationship is many-to-many. This means volunteer can have many assignment, and assignment also can have many volunteer. Go to the distribution record. The primary key is distribution ID. The data type is number, and the relationship between relief center is the relief center can have many distribution record. Go to the add item. The item ID is the primary key, and the relationship between distribution record and add item is the one add item can distribution multiple times. The last relationship is recipients between the distribution record. The recipient's ID is the primary key, and distribution ID is the foreign key in the recipient's table. The relationship between these two is one-to-many. This means one recipient can have many distribution records, but one distribution records only can belong one recipient. This is all the diagram.
Good day everyone, my name is Soyu Pei. Today I will present the user's constraints on disaster relief and emergency response, and I will briefly explain why each of these constraints is necessary. First, the age of the volunteer must be 18 or older. This constraint is mainly to ensure that legal requirements are followed and at the same time to protect the well-being of volunteers who are involved in disaster relief events. Next, the emergency contact number must be valid. In disaster situation, accurate and accessible information is very important. Having valid emergency contact numbers helps with coordination among volunteers, victims, and responders during disaster response activities. Another important constraint is that the distribution date cannot be prior to the disaster start date. This ensures logical consistency in the system and avoids recording distribution activities for a disaster that has not yet occurred. As a result, the data used for tracking relief efforts and reporting becomes more accurate and reliable. The next constraint is that the relief quantity must be positive. This prevents incorrect data entry such as negative values and ensures that supplies like foods, waters, and medicines are properly recorded. In addition, volunteers' working hours in a day should not be more than 12. These constraints help protect the health of volunteers and support sustainable practice during disaster response operation. Finally, the aid type should correspond to the disaster type. This is to make sure that appropriate resources are provided during emergency. For example, water and blankets for floods and medical kits for earthquakes. That's all for my present. Thank you.
Now I'll be talking about the implementation of the database using the SQL script. As you can see, we have created a table and we have also inserted the fixed test data into it. Now let's try running it. As you can see, all of the statements are processed successfully. For a much more detailed view, we can look at here. These are all of the SQL script.
Today I'll be going through the SQL code that we wrote for a database group assignment. So we created a database for a natural disaster relief center. It has 7 tables, that being the disaster event, the relief center with all the information regarding relief center, like the location, the contact numbers, the person, etc. Table for the volunteers database, and a table for the assignments, table for the aid items available, and another table for the distribution record, and lastly, table for the recipient. Following that, we have SQL code to populate the tables with all the relevant information for that table. So some of the queries we wrote were, firstly, one is to show which relief centers are handling each disaster, including disasters without centers. This code over here has a left join. It includes all disaster events from the disaster event table, and relief center information is included if available, but disasters without relief centers will still appear. So the table will be sorted by the severity level of that certain disaster in descending order, with the disaster name also being included. This next piece of code identifies volunteers who are available or completed past assignments. It returns all volunteer ideas who have at least one completed assignment. The main queries then includes volunteers whose IDs is on the list. Next, we have code that finds all the volunteers assigned within the last 90 days whose name starts with A. So over here we have an inner join between the volunteer and assignment tables. It only returns records where a match exists in both tables. And this next piece of code shows the total aid distributed per relief center. It selects centers from the relief centers identifies certain codes with above average distribution totals, calculates the average quantity from all distribution records, and is ordered by the total distributed in descending order. And lastly, this last piece of code lists the relief centers with the highest A distributions and the volunteers assigned there. Selects the center name and volunteer name from the relief center table, and has multiple joins between the distribution records, intercode, etc. And it returns the maximum or the total quantity of the relief centers that have the highest A distributions.